In this lesson, we're going to extend our ideas about stretching, compressing, and reflecting to things that involve parent functions. So you probably want your parent function sheet out handy so you can remember the tables of values. Down the road, when it gets to testing time and such like that, you're going to have to know those tables of values. I'm not going to give you the parent function sheet. You're going to need to know your tables, your domain range, and basically your shape. Okay. Everything we've done with regular old functions, any random functions, you can do with a parent function, because parent functions are functions. So let's start off simple. Let's pretend that in one of our parent functions, we had a point 4, -2. I don't know what parent function is at this point, but it's a parent function. Can I find the coordinates of the image point? An image point is something that happens after you transform a point. So if I look at part A, what do I notice? I see an A value of 3. That's a vertical stretch by a factor of 3. What does that do? It multiplies my y values, vertical things. So if I triple the y value, the 4 will stay the same, but -2 becomes -6. That's my image point. Okay, if we try B, what do I notice going on here? I see a negative and a 4, which would be a horizontal reflection and a horizontal compression. Because if you remember, K's do the opposites. So how would I get that? I would take my x value and I would divide it. Remember, k's do the opposites, divided by -4. So 4 divided by -4 is -1, and the y value would stay the same. There's the image point for that one. Okay, let's try C. Oh, all kinds of fun stuff in C. What do we see going on here? Okay, I'm not always going to write them out, but you should know that there are 3 things happening here. Okay? A has 2 parts to it. It's got a negative sign, a vertical reflection, and a half, a vertical compression. The K, it's an opposite, so divide by a third actually ends up multiplying by 3, a horizontal stretch. What would we do to get our image point? We take x and divide it by a third, which we know is the same as saying 3x. And our y's, we'd have to multiply it by -1/2. So what is 3 times 4? That's an x value of 12. And -2 divided by -1/2 comes out to +1. Okay, we're transforming points like we did yesterday, except for yesterday we started with tables we got from a graph. Well, parent functions are really just a set of points. They're tables, right? As long as we can identify which parent function we're working with, we can identify its table, its domain and range, we should be able to apply our transformations to those things. So in this example, we're told that y equals absolute x. That's a parent function. In particular, it's a parent function that has the table -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. And that table has a domain of all real numbers, and y has to be greater than or equal to 0. Actually, let's write it the other way just so we're familiar with it. Y has got to be greater than or equal to 0. That's what we have to recognize from the question right off the bat. This is our parent function, the v shape. I want to transform that. I want to do 3fx. I want to do a vertical stretch by a factor of 3. How am I going to do that? I'm going to triple my y's. So x's stay the same. Triple the y's. 6, 3, 0, 3, 6. And we know our domain hasn't been touched because we didn't do anything to the x's. So it's all real numbers. But our range, when we triple them, multiply by 3, 3 times 0. Oh, it's still 0. So in our graph, we should only get numbers bigger than 0. Let's try it. -2 and 6. That's right there. -1 and 3, 0, 0, 1 and 3, 2 and 6. Still a V shape, been stretched. Never goes below 0, so my range is right. Still goes left and right forever and ever and ever. My domain's right. Yeah, got it done. It also asks us for invariant points. Which point has not moved? The only one here is 0, 0. In our table, it's the same numbers. In our picture, it's the same numbers. Let's try the next one. Negative 1/2 fx. What's happening? That's a vertical reflection and a vertical compression. I need to take my y values and multiply them by negative 1/2. X's will stay the same. My y's all get cut in half and they become the other sign. So negative 1, negative 0.5, 0, negative 0.5, negative 1. My domain hasn't been touched. All real numbers still. My range, I got to multiply 0 by negative 1/2. Well, that's still 0. But because I multiply by the negative, my inequality has to change direction. Now we can write it that way, or if you want to, you can say y is less than or equal to 0. It means the same thing, right? Just whatever way you feel more comfortable writing the order of things in. If we graph it, negative 2, negative 1, negative 1, negative 0.5, 0, 0, and so on. We get this shape. And what has happened? It's been reflected and it's been compressed, which makes the V wider. Do we have any invariant points? Sure do. 0, 0 still hasn't moved. Okay, so there's a parent function idea of how we can use transformations on it. Let's try the next one. Determine the domain and range of y equals negative 3/4 fx, given that fx is x squared. Here's my parent. And all I'm asked this time is domain and range. So all I need to know is domain and range of parent. Domain of a quadratic. Left and right forever and ever and ever, right? Range, it's always greater than 0. Okay, I need to transform that. I need to do a vertical reflection and a vertical compression. 3/4 of y. What's going to happen to my domain? Absolutely nothing. Still all real numbers. Still quadratic. Quadratics go left and right forever and ever and ever, no matter what. Our range, I need to multiply 0 by negative 3/4. Well, it's kind of like we did the last one. 3/4 of 0 is still 0. Because I have that negative sign in there, I need to flip the sign. And if you can write it that way, or you can write it this way. I don't care which way you do it, as I said, as long as you're comfortable. Done. Okay. Parent functions. Next one. fx equals root x. Well, we know that's the parent function. Square root of x. What does that look like? X, y, 0, 0, 1, 1. We could square root 2, but it's a decimal, so we skip to the 4. And we skip to the 9. Our domain for this one, x has to be greater than 0. And our range, y also has to be greater than 0. Can't have roots that are negatives. All right, let's do some transformations. Oh, we got stuff inside the brackets this time. Those are k's. Those are x things. We got to take our x's and we got to divide by 2. Okay, let's see what we get. Half of 0, 0. 0.5, 2, 4.5. Y's stay the same. Okay, half of 0. Well, that's still 0. Didn't touch our range. Graph it. 0, 0. 0.5 and 1. 2 and 2. 1, 2, 3, 4.5, and 1, 2, 3. There's our function. Done. Yeah, try the next one. Again, I got something inside the bracket. That's an x thing. So let's make it letter k. I do the opposites. So x divided by 1/3, we know that's 3x. So we're horizontally stretching this time. And it's triple our x's. 3, 12, 27, 0, 1, 2, 3. Didn't change. Domain, triple 0, still 0. Didn't touch the range. Graph it. Now, obviously, this is not going to all fit in the graph. We'll just fit what we can. 0, 0, 3, 1, 12, and 2. That's way over here somewhere. It's a big, long thing like this. Okay. Still working with the same parent function. We're going to try some more. C and D. Okay, a negative sign. What does a negative sign do for us? That would be a horizontal, because it's inside the bracket, reflection. Divide your x's by -1. And we're still working off that red table, right? Same red table. 0, -1, -4, -9. Okay, our range stayed the same, but our domain, when I divide by -1, I got 0, but I got to change the order. Okay, now you don't like that, you can write it this way. Our range, 0. Okay, so it says x should be less than 0, y should be greater than 0. So it should be left and up, if you think about it. Let's try it. 0, 0, -1, 1, -4, 2, -9, 3. Sure enough, that graph is going to the left and up. I know it's left because it's greater than 0, and up. Sorry, less than 0, and up because it's greater than 0. Okay, let's start putting things together now. I've got a vertical reflection, a horizontal reflection. X is by -1 and y is by -1. What are we going to get? Well, 0, 0, still 0, 0. Okay? Everything else, our signs are all going to switch. Right? That's all that's happening when you divide by -1 or multiply by -1. What's going to happen to our domain? Our domain, I got my 0, but I got to flip the order. My range, I got the 0, but I've got to flip the order. So in other words, x is less than 0, so below the x-axis, and sorry, x left of the y-axis, and y is below 0, so below the x-axis. So if we graph that, 0, 0, -1, -1, -4, -2, and so on. And a double reflection. Got reflected one way and then the other way. Okay, so we're working back to parent functions. Okay, last one. Describe. So I want you to use words for me. How the following graphs can be obtained from the parent function. State the domain range for each function. We got to identify the parent function first, right? So if I look at the first one, if I get rid of the number that transformed it, and we don't usually have 1 as a transformation, so the only number that's really transforming it is the 4. If I get rid of that, I got my parent function. My parent is 1 over x. So the question is, what does the 4 do? Does it affect the x's or the y's? Is it the a value or the k value? So here's the idea for you. Okay? A fraction acts like a bracket. So that really means it's like this. The 4 is affecting the x's. It's a k value. So what does a 4 do then? Well, that's a horizontal compression by a factor of 4. Now, why is it a compression? It's in front, and x's do the opposite. So if I was doing my transformation, I'd bring x divided by 4. Okay, domain range. Well, I gotta go back to my parent function. What's the domain of this? Everything but 0. Range, everything but 0. So if I divide 0 by 4, what do I get? I still get 0, and we didn't touch the y's. Okay, try the next one. What do I see? If I get rid of the numbers, I'm left with my parent function. So there's a number here, there's a number here, my parent, and that's root x. What's the domain of that? Gotta be greater, my range also has to be greater than. Okay, let's go back and think about our transformations now. Which things are x's, which things are y's? This one's a little bit more obvious, but in this case, the root sign acts like the bracket. So this is the same thing as saying, in a different way, y equals -2 f 1/3 x. And that one's a little bit easier to tell because the root sign kind of looks like a left-hand bracket. So what do we have to do? We have to describe. So we've got I got 3 things going on. I've got a vertical reflection. That's my negative sign. I've got a vertical stretch by a factor of 2, because this is a, that's outside the bracket. And I got a horizontal Also a stretch, because remember x's do the opposite by a factor of 3. There's your k. So what do I need to do to get my new domain and range? I've got to do negative 2 times the y's and x divided by 1/3, which we know is 3x. What's our new domain? That's supposed to be greater than 0. If I times that by 3, I still get greater than 0. Y is times it by negative 2. I still get 0, but I multiplied by a negative, so I got to switch the order. There's my new domain and range. Okay, that's the end of the lesson. Domain and range. The homework for this is on the back side of the handout. I did the handout together to make our life a little bit easier today. Okay, if you didn't print that off, you might want to print that off so you can get the homework off of it. Okay, we're going to finish the sheet that we started yesterday. So questions 6, 7, and 8.